All right. So I want to welcome everybody to our webinar on vacuum technology. Um, I'm Chris Hopkins. I'm out in Livermore, California, and our tech center out here. Also here with Kyle Newman. He's the manager of applications at Datron Dynamics. He's based out of the New Hampshire office and runs the New Hampshire Tech Center. Today, we'd like to go through talking about challenges with holding flat material, fixturing challenges there. Also do a demonstration on just understanding how Datron's vacuum tables work, and then do a live show of actually milling apart, flipping, being able to find on both sides, and having a finished part right off the machine without having to do tabs, any secondary processes. We will have a Q&A towards the end. If you want to put any questions in the chat, and we'll get to those at the end. Going to be going about 45 minutes to an hour today. So with work holding, there's many different ways you can hold parts. But when you get into flat parts or thin materials, usually you can't use the traditional methods of clamping, or you have to create fixtures. Vacuum tables have been around for a little while. There's different types. There's types that are with gaskets and venturi. What we use is a vacuum pump to make up vacuum for it. There's also double-sided tape that you can use. That's been a kind of a trick method that a lot of people have started to adapt, where you tape on both sides of the part and then glue. But it takes quite a bit of time to set all those things up. There's definitely better ways to hold flat material using vacuum. The best parts of that are really that you don't have the large amount of setup time. There's also situations where flat material will warp and things like that. So being able to have a vacuum where it's holding it evenly across the whole part is helpful. Do you want to talk a little bit, Kyle, maybe about the Datron vacuum tables and how those work compared to, say, like a normal venturi and gasket type?
Yeah, absolutely. So I think one of the big things that sets Datron's vacuum solutions apart from other systems that are out there is how the whole system's kind of cohesive and it all works as one. All our machines have through table vacuum ports, and all our vacuum tables have through vacuum ports on the bottom, so that you can put them into our conical system, which helps align everything repeatedly, and you're able to swap on a vacuum system, bolt it down, torque your bolts, and go. And one big difference is most other systems are using a O-ring or some sort of fixed gasket. Our vacuum card sacrificial layer, which is a proprietary cardstock layer, creates a gasket that conforms to any part. So you don't have to rearrange the vacuum table for each individual part. You're able to go in there and you're able to set it up and run the same vacuum card for a variety of different parts. So I think that's the main thing. And then we're also using large industrial vacuum pumps with high CFM. So we start anywhere from 28 to 200 CFM, depending on the table. And what's nice is we have a solution for every machine. So everything from our Neo, which is roughly a 16 by 19 work area, all the way up to our ML Cube, which you're looking at 60 by 30, 60 by 40. So you have a large different varieties, and it's kind of plug and play on our machine. So it swaps off, allows you to put other fixtures, and allows you to be versatile in that way. And then those large CFM pumps, we make up for when you drill a hole into a part, you don't have to have a gasket it off. Our vacuum card makes that gasket, and then our industrial vacuum pumps make up for any vacuum loss there. So you're able to hold some interesting parts that would be very difficult on an existing vacuum solution from another manufacturer, or using traditional clamps, bolts, or screws.
Kyle, how is there certain types of materials that are better for used on the vacuum table, or how do you deal with cut throughs, things like that, without damaging the vacuum table?
Yeah, so one of the really nice things is in our Datron Next Control, there's something called protected areas, which you can actually probe your vacuum table surface and you create a protection area. So that helps from any errors. Also, the vacuum card is a sacrificial layer that you will actually machine into. So what's nice is you can actually go through the bottom of the part, and when you bore a hole, you can go all the way through into the sacrificial vacuum card. It also allows some opportunities with, say, a small dovetail to break the back edge and do some parts that would be multiple operations in a single operation. So it's really flexible there. As far as materials, flat is important. So you do have to, the surface has to be able to conform to the surface of the vacuum table to make a seal with the vacuum card. And you can hold acrylics, aluminum, brass, copper, thin sheet metal. Those are the kind of materials we're having success out in the field with.
And compared, I know when you're using flood coolant and things like that on different types of machines, this wouldn't work really with the paper. So that's where it's more of a better fit for the gasket type.
Yeah, absolutely. So that's one other benefit is we typically, for non-ferrous materials, our customers are using an aeroblast in plastics, and they're using ethanol alcohol for most other applications. So it's evaporating immediately. It doesn't have time to soak into the sacrificial layer and cause any issues because it evaporates so quickly. So kind of that whole ecosystem all working together makes for a really versatile system. And then for ferrous materials, there's opportunities to use a lightweight cutting oil in our MQL system, minimum quantity lubrication, which is just a spray system. And you can use different techniques and spray patterns to reduce the soaking of the vacuum card. So you can hold parts that are ferrous and you need to cut with a cutting oil.
And is there any tips or tricks that you could give for, final cuts, things like that? Because if you're cutting out a part all the way through, how does the vacuum still hold that? There's got to be, obviously you have a lot of makeup with the high CFM pump, but you still have to have some tricks up your sleeve there.
Yeah, absolutely. So when I'm consulting with most customers or working with them or prospects, I explain to them it is kind of a simple math problem. So perfect vacuum, you have 14.7 psi of holding pressure for any remaining area that's being held on vacuum, and that's at sea level. So you can kind of use that as a calculation to see what kind of holding forces you're going to see on your parts. And I usually take 10 to 13% off of that because you're never going to create a perfect vacuum. So we find that our vacuum pumps are losing about 13 to 14% from perfect. So we use that. And as far as tips and tricks, so after you've done the calculation of if it'll hold, there's little secrets like I'll leave a small foil or tabs so I can aggressively cut a part just like I would cut it in a vise. And then you come back and you leave a small foil on the bottom floor. And then you take a smaller end mill and you put less tool pressure on that tool. And you come back and just clean that foil up. And then you can break the edge. And what ends up happening is you're able to hold complex parts with minimum surface area and have a perfect part right off the machine. So there's all kinds of tips and tricks using thread mills. Also, there's an opportunity to use some thicker sacrificial layers if you need to drill deeper and account for an angle for your drill, or to be able to get a thread mill in there and do a through thread. We have sacrificial layers that are a little thicker that are made out of fiberboard.
And if your part's smaller than the vacuum table, how do you deal with open area there?
Yeah, so one of the interesting things is on our meandering group vacuum tables is they're sectioned out into 100 by 100 millimeter sections. So we'll show that a little later when I'm at the machine, and you'll see it in the video we're going to play demonstrating a part. You can actually shut off each zone, and that's the most important tip of any, is to always maximize your vacuum hold and wait to cut out your parts till the very end. That's kind of the secret, is order of operations becomes very important in vacuum holding, trying to maintain as much surface area until the very end, and then putting at least pressure as possible on the part as you remove that final pass.
Awesome. Now, do you want to go into maybe showing us how this works visually?
Yeah, absolutely. So what I can do is I'll switch over the camera and I'll go to the table and I'll demonstrate kind of how the machine's set up, and I'll show you our Neo vacuum chuck, and then we can take a look at some of the physical parts. So what you'll see in frame over here is we have our vacuum table here. This is our M8Q. It has a 40,000 RPM spindle, so that's another benefit of our machines. The higher RPM spindle allows you to run tools more efficiently with a lower chip load. So on the table, you're not going to be able to see right here, but about in the center of the table, there's a through vacuum port. That's what actually feeds the vacuum up through the bottom of this table. And this is our elevated table, so you're able to get maximum reach with small tools, and it allows you to fully reach the bottom of the table. Each one of these, show you, this is the Neo version. It's just a smaller version of what you see on the MAQ. And you'll see there are black rubber stoppers on each section, 100 by 100 meandering groove section, and that allows you to shut off and contain vacuum to those areas. So it becomes really nice to be able to focus the entire vacuum on, say, 100 by 100 millimeter section. And then what I usually do is pre-lay the part on it and then figure out what size it is, and then I can shut off that vacuum zone at that time. So also what's nice on our control, everything's activated from the screen. So you can turn on your vacuum pump from the screen. You can also turn on different vacuum ports to activate those. And it also has, I told you about protected areas, how we build in the ability to protect the table and create a no-go zone for the tool. We also have the ability to monitor the vacuum pressure live and pause the machine if, say, you took too much material or your vacuum pump shut off. It allows you to pause and hopefully save your part. So you can see we have an arrangement of good parts. Everybody always asks, like, what's a good vacuum part? The biggest thing is at some point you have to have a flat side. You have to have flat surface area on one of the sides to be able to hold it. So that's usually where I start when giving advice. So a lot of flat parts, but at least have to have the flat side on one part so you can hold it on that final operation.
In how do you work with two-sided parts then? So can you flip a part on the vacuum table if there's.
Yeah, absolutely. So one thing we'll show you is the built-in probing system on here. It's really nice. So our old control, we've always had probing routines. The new control being augmented reality with the camera, being able to draw your probing cycles makes it really easy. So what I usually do is if you have a machine flat edge, you can indicate after you machine your side and flip the part over, you can indicate on a machined edge, or even better, if you have two through holes, you can use one of the holes to set your origin and set your 0 point on there, and then you can use the other one for rotation. So that's an important point that Chris pointed out is when you're working with vacuum, the first side's fine. You're going to cut it out, it's going to be good. When you go to flip it over, there's no easy way on most parts, unless you have square edges and use a stop, to reliably align that part perfectly so all your features match up. That's where using the probe and probing cycles to align those features and calculate the rotation makes it really straightforward and easy. And you'll see that in the video we're going to show you. And then you'll see, yeah, we use a proven routine to probe each of the holes and calculate the rotation. And it's automatic. You don't even have to think about the control, so it makes it straightforward.
Even on maybe some thicker materials, say it's 1 inch or 1.5 inch thick aluminum, your first op could be on a vacuum, and then the second op you could have in soft jaws or
yeah. So like that too. A lot of our customers will batch mill their parts. I'll first stop on the vacuum, and then they'll go put them onto a set of soft jaws and some vise and work it that way, or use another complement. It's a great complement to other work holding. And it makes the first stop. You don't have to worry about screws and bolts and avoiding that. So it can be really flexible in those situations.
Do you want to maybe we can switch over and watch the that part mill that you just had in your hand?
Yeah, absolutely. All right. See, I'll give you a little run through. So you can see Justin Rice, our application engineer, is setting up a part on that MAQ behind me. And right now he measured the stock, so he knew which vacuum ports to shut off, and he's consolidating the vacuum using those vacuum ports. And the idea is to only use the space that you're going to cover with stock so that you can concentrate your vacuum there. He's now putting our sacrificial layer. What's nice is we make a variety of sacrificial layers, different sizes to fit all our vacuum tables and applications. And we can talk a little more later. There's some adhesive versions to help where you're using adhesive to hold, and then you can hold some really small parts. And it's really repeatable and easy. You don't have to use double-sided tape or super glue. So right now he's going into control and he's going to actually load our toolpath code. So he's loading up our program for the top side. There's going to be a top side and a back side program. And now what our system does is it checks for the tools in the tool tray and it makes sure it matches the program. You can see he's activating the vacuum right now and it's pulling negative 0.87 bar. Okay, next he's going to probe. So the nice thing is it switches to the augmented reality camera and you're able to set up a probing routine just by drawing on the screen. Super important, you'll see on the backside for measuring small features and aligning your rotation up. See, it's probing 3 points to find, it's calculating rotation on the 2 points and it's using the other point to find the bottom left corner. And then it goes through a simulation. What's really nice is this will tell you if you violate your vacuum, your protected area. So to give you a heads up, if you enter the wrong code, the machine will stop, but this prevents you from running the code. And you can go in, you can play the simulation, and it actually visually shows you all your protected areas in that yellow color with the tool. And you can see that it's not going into those areas. And it also shows you the 0 point that he just probed on that bottom left corner on the top of the material. Now he's going to execute the program. So Chris asked about optimal tooling strategies. In this case, you would just mill it just like it's in a vise. You're not going to lose pressure. There's hundreds and hundreds of pounds of pressure holding this plate on the ground. You have hundreds of pounds of holding force. So we're just bore milling a hole with a single flute end mill. You can see our ethanol coolant on there, which helps. It evaporates immediately. And now we're switching to a contour. So one important thing is I typically will ramp down. What that does is it keeps a constant tool engagement so you're not shocking the part and moving that inner piece that's getting removed. And he'll leave a very small foil on the bottom, which he'll go then clean up in a finishing pass. So it applies less pressure on that center, so you're not getting that center piece shifting. You can see the center slots were cut the same exact way as the center one, and now it's doing an exterior contour with the same ramp down. And what's nice is, so somebody would ask, should we pocket that circle? Would that have been more efficient, that we don't have to worry about it? In this case, you're preserving quite a bit of vacuum work holding by just having the 3mm slot where the tool is. So by leaving that plug in there, you're preserving vacuum as long as possible, which is the key. And he's going to leave a very small foil here. And he's going to come back. And this strategy works with copper, brass, aluminum. It's all the same. What's really nice is, so one of the side benefits, if this works for your application, is aluminum. It'll actually bend the plate down a little, so it'll fit with the vacuum. But you got to be careful. You have some pressure applying the other way when that releases from vacuum. So you can see he's just taking a final pass, barely cutting into that vacuum card. And then he's going to open the door, and you'll see it just cleanly comes off. You don't have to think about it. He turned the vacuum off on the control. Oh, there's actually a chamfer going in. So now he's going to chamfer it. And just for the other side that he's going to run, there's an actual chamfer and an engraving on the other side to show a backside operation. And speaking of order of operations, another important tip is take the aggressive cuts up front and then take your lighter cuts after you've started releasing vacuum. Then you're putting less pressure on that part and it's less likely to shift on vacuum. And the nice thing is, versus like a vise where if you lose the part, it's going to probably come out pretty energetically. In this case, usually if you overcut or too aggressive, it'll slide, you'll see that and you'll be able to stop the part. It's less destructive than when a part comes flying out of a vise. Just finishing the final chamfers. And you'll see he was able to deactivate the vacuum right on the machine. Now he's able to go in and simply pull the part off. And the nice thing is this is a burr-free, clean part that's ready to go and be flipped over for the second operation. So now we're cutting to him doing the separate operation. He just turned the vacuum pump on and he's going to hold it like this. I had him purposely put this at a large angle. You wouldn't typically want to do this, but it's going to show how it makes up using our rotation calculation using the probe. So now he's in the camera probing. All he's going to do is draw two circles. So he's going to move those in and he's going to probe the point. And in my CAM software, I set that first circle as my work coordinate system. And you don't have to do anything with the second circle. The control knows that second circle is for rotation. It assumes it's in line with that. So now he's going to hit probe, and it's going to start probing. And you'll see we have a small 1 millimeter probe tip, which is nice. You can get down to a 1 millimeter probe tip on our machines and probe some pretty small features. And it's just finding the center of that circle on the top of the stock, and it just set 0. And now it probed the second one, and it calculated rotation. And you'll see this is just showing the axes moving as it's probing. But you'll notice that that rotation icon is going to show up in the center of the screen and turn green. And when he presses it, you'll see there's 6.75 degrees of rotation. So it already calculated, it rotated the X and Y coordinates of the machine automatically as it runs the program. So all he did was hit run. He's going to do a simulation real quick, make sure there's nothing wrong. And you can see the origin is actually set in that circle. You can see it in the simulation. So it's really nice. You're able to double check the simulation in your CAM software and then compare that to what you see on the control and get a great idea of what's going to happen. So you'll see now we hit run. It's going to come down and it's going to be perfectly aligned. So that's one of the things. Without having probing ability, to get that accurately and perfectly aligned when you flip it over to the backside would be difficult. So we make that really simple and straightforward. And that allows you to do the 2-op parts that are straight off the machine. No need for secondary finishing, no need for cleaning because you're using the ethanol. So it all works really well as a system together. And this, you can see, we kind of sloppily laid it on there. The nice thing is there's not much cutting force. So that's another thing you would need to take in consideration is how much cutting force there is. It may make sense to leave this, say you nested these out, to leave them panelized with material in this and actually flip it over with the whole sheet still intact with 2 holes you could use. And then you're holding more, so you could do more aggressive. Say you had to cut another pocket on the backside. So different strategies you have to think about for each application. Now the door's going to unlock. You'll see it's nice. The part comes off, ready to go, ready to clean, just cleaning some chips off it, and you are ready to ship it out. So yeah, that's one of the nice things about that setup.
Quick question, especially in plastics, flatness is usually an issue. What are some ways to, basically compensate for that so you're not cutting too deep or
and that's actually and that's another great feature we have. So there's a couple of ways to handle that. One feature we have is called surface profile. So you can probe a field of Z points on the material, and that'll help compensate to make sure you're cutting all the way through. In this part, we didn't use it. For this case, it was actually okay just to use a single Z height to set our origin, and then go back and just cut deeper into the vacuum card. So we went 200 microns deep. So we went about 5-10 thou deeper than the part to actually cut into the sacrificial layer to ensure we cut all the way through. But like you said, yeah, acrylics, plastics, that is a huge concern. Flatness on the material, so that is definitely something you have to take into account. So you can either do that with surface profile, if you don't have the benefit of being able to go 200 microns to 300 microns past the back of the sheet.
And those tables, they're machined on the machine, so they're totally true to the machine.
Yeah, that's a great point. So one of the nice things is between the conical system and the way we prep the machine is when you put the vacuum table back on, there's no need to remachine it, tram it in, or do anything for that. What we do is we face mill it on the machine, and the benefit of that is it's true to the axis. So it's flat to the axis of the machine, and that allows us to get flat, repeatable, high tolerance parts off the vacuum system.
Awesome. Thanks for doing that and demonstrating it.
Yeah, no problem.
What I'd like to talk about now is how are people using vacuum tables, or what type of parts are they making on them that maybe some of us recognize?
Yeah, yeah, absolutely.
I know the origin of the vacuum tables, at least in the U.S., came from a knife manufacturer. trying to cut scales for the handles and knives. And that's mainly batch machining. So, putting down a whole sheet, cutting out multiples of the part, sometimes even tabbing and flipping and cutting the tabs off and things on the second out. What other applications have you seen?
Yeah, so there's definitely a lot of applications. Anything that has flat plate work is obviously a great fit. Die manufacturers are using this a lot. So somebody who wants to, either a one-off die and it's just easier, you don't have to pull out the vise every time. But the real secret is nesting dies. So instead of making 1 or 2 dies at a time with a couple of vices, they're laying a full plate of brass out and making embossing dies or foil stamping dies in huge quantities. So imagine an ML cube, 60 by 40 inch work area that they have packed full of dies. They hit it and they come back 24 hours later and they've got 3, 4, 500 dies sitting there, smaller dies sitting there ready to go, clean off the machine. No need to secondary process, because what we found in the die making application is a lot of customers were having to grind the angles for their presses and do all that. We're able to do that right off the machine and it comes off clean. There's no secondary work. It's ready to go to the press and start being used.
And 40 by 60 lends itself well to larger plates too, right? So like, I would think fixturing plates, things of that nature would be perfect for it.
Yeah, absolutely. Aerospace, isogrid type aluminum structures, bracketry. Yeah.
Yeah, and even I think the first webinar we did, we talked about microfluidics, and that the vacuum table is hugely like a benefit to them because quick iterations, just being able to take a part on and off the vacuum table without making fixturing.
Yeah, absolutely. Them being able to go straight from their CAD software right onto the machine, not think about how they're going to hold this one-off part or move the vices, and they're able just to throw it on vacuum and cut it out. And some of the other features we have along with the vacuum table, as you know, acrylic or PMMA can be really inconsistent. It allows them to solve a lot of those problems.
Yeah, and some of the parts I actually put the origin at the bottom.
Yep. And that's another
I know
good
exactly where I'm
so,
coming from on the part then for my through cuts.
Yep, absolutely. Yeah, if you want consistent through cuts, the best thing to do is to use the bottom as your 0 point, and then if you go 5 thou past that, you're absolutely going to nail it because it's right off that paper, and it being machined to the axes of the machine and the vacuum paper and the vacuum card system, it's very repeatable and very accurate. So you're able to use that repeatedly.
I don't remember the number off the top of my head, but how thick is the paper?
It's about 30 thou.
About 30 thou. Okay. And I think the other application I've seen is like fuel cells. We've done some stuff with that on vacuums. Really, the thin material that's going to warp. There's no real good way to hold it. You get down into 60 thou or less on some of these materials, and vacuum is really the only way to do it.
Yeah, one nice application is even stock prep. For them to be able to easily flip the piece back and forth and flatten it and machine it flat is beneficial to them. They don't have to figure out how to hold it in a vise and are they putting too much tension and further warping the part. They're able to relax it on vacuum, machine it off, flip it over, and machine it and get a really good result for parallelism.
Yeah, sometimes you don't even know if the part's warping or not. It depends on how strong a person's arm is.
Yep.
Is there any other tips or tricks that you want to give, or should we go into the Q&A?
Yeah, no, I think we covered most of it, and then we can cover anything in the Q&A.
I got one question here. It says, roughly what CFM would be required for, say, a table setup that is 1,000 by 1,200 millimeters overall, using the normal vacuum card and fairly big parts?
Yeah, so the part size definitely comes into play. Our standard recommendations about a 200 CFM pump. So in that size, in the 1,500 by 1,000, we recommend a 200 CFM pump. If you are cutting large parts that don't have a lot of material removal or through holes is the main thing. How much material is staying intact, what surface area is staying intact with the vacuum table, you could probably go down to the 120 to 130 CFM range. And that's something one of the nice things is you can consult with the applications team. We could look at your specific parts and give you actual feedback based on the surface area of your average part.
What's the smallest part that, say, you've made or you've seen a customer make
Yeah.
And what's the process of trying to make, miniature parts? Everything's getting smaller now. There are big parts out there, but at least consumer electronics, things like that, everything's getting smaller.
Yeah, that's always my favorite question. So when I get that question, I go, well, there's a lot to it. So I have personally held a half-inch by half-inch diameter Teflon disc that was Swiss cheese, just with hundreds of holes. I did use the Vacuum Card Plus Plus, which has our adhesive grid on it. So it acts as an adhesive layer, and the parts being held on that. And then you're able just to, I typically spritz it with a little ethanol. That's luckily we're using for the coolant, and it falls right off, or you can just pull it off and clean it up. I typically tell customers a no fuss part that you don't have to worry about too much is a 100 by 100 millimeter part. Something like this size with that kind of material area removed, I would guess there's probably, I don't know, 60–70% of that material is removed. But I did keep the circle in the middle to retain most of the work holding pressure. So I've seen some really interesting things done. The benefit of vacuum is it just doesn't have to hold on vacuum. So we have customers that will make plates to hold one of their low profile vices, and they'll throw it on the vacuum just because it's so easy to put the vice on vacuum, use that, and use other work holding techniques in conjunction with vacuum just to make it really easy and straightforward to swap quickly.
So next question here I got is, does the vacuum card compress? Curious about Z accuracy. We frequently get requirements for +0, -half a thou. Would vacuum be a good option for that?
Yeah, so I will say it will compress. I say it depends heavily on how heavy your part is. If you're putting hundreds of pounds of stock, yes, it'll probably compress slightly. At 5/10, so half a thou, I would say yes, that's a part you could look at vacuum for doing. The consistency over that sheet of vacuum card, the way it's manufactured, is very consistent. From batch to batch, roll to roll, it may vary more than 5/10, but in the end, in that batch, it's very consistent and across that sheet that you're going to have over your table.
In how much, next question here, it says how much vertical compression occurs in the vacuum card sheet during vacuum hold under typical operating vacuum levels?
That's a great question. I don't know if I've ever measured it, but I would assume it's a few microns. I don't think it's a significant amount. And that's where Chris was talking about. All our probing and measuring is going to be done under vacuum. So if you use the probe to counteract, if you're using you're probing off the paper after it's compressed, that you're going to get accurate results. So you can use the probe and some of the techniques to make up for some small amount of that if you need to. And that's where our application team, anytime a prospect comes to us and is looking at our vacuum holding technology or our machines, we sit down, we have a consultation with sales, and we work through the process to make sure it would be a good fit for your application.
Next one, a lot of vacuum card questions. Are there other sacrificial materials you can use in different situations instead of vacuum card?
Yeah, absolutely. So there's a couple. They range from very elegant to the standard. So you can use like porous aluminum on top. That's an option. If you're doing a fixture that you're going to reuse a bunch, it may be worth investing in something like a porous aluminum to make a fixture out of. There's something we sell called Magic Board. It's a low density fiber board, so you can use that with sealed edges. And what's nice about that is that's a great second op thing. You can use the standard vacuum card to make your first cut in your first operation, and then keep the whole sheet and flip that over into almost a reverse cavity, almost a soft jaw made out of low density fiberboard. And so you have a little bit of mechanical hold and combining it with vacuum. And we've had knife manufacturers who've done some of that for their scales and knife handles. So you can get creative and do that. I say the limit's your imagination. We have the Vacuum Card Plus Plus, which has an adhesive grid. One really unique thing that works out really well sometimes if you have the Z accuracy, so when our machines were able to do this, is you can leave the protective backing on your acrylic or the adhesive sheet on the back, and you can actually use that to hold your part. So it's almost acting as your adhesive layer, and you go and you machine down and just very accurately, and like Chris said, this is probably where you would probe off the bottom of the part, and you keep it consistent, and you don't cut into that. And then you can pop it off, and it's actually being held by that adhesive sheet. And then it pulls off cleanly, and you've got a nice finished part. So there's different strategies. Between everybody at Datron, we have a lot of experience. I would say when I'm making parts and doing prospect, usually I would say 60 to 70% of it's probably on vacuum. So we're really used to it. We have out-of-the-box ideas for out-of-the-box parts.
I have a follow-up question. It says, will the compression of the vacuum card be relieved as the through pockets are added?
No, typically not. So most of your compression is going to be, at least on the scale that on the non-microscopic scale, it is going to be pulling your material down when you release. So there's a caveat there. If you take a huge cut and you were to mill out a pocket and release 90% of the material there, yes, you may see some shift in the part and the paper. And that's where the strategy is, like on this particular part, making sure we left the slug in there, help maintain vacuum so you're not going to see that lifting. One thing to keep in mind though is if you have aluminum or something under tension that has stress in it, it's possible you're going to pull that sheet perfectly flat on the vacuum typically. Under say anything under a quarter inch, you're going to pull that flat. If you do release a large part, you can see that potato chip up and end up with that situation. And we have strategies and material recommendations to help avoid that.
Here's an interesting one. I don't know if it's a great fit for a Datron machine, but it says, I have a customer cutting 7/18 Inconel, quarter-inch thick in a dog bone shape. Would your vacuum chucks work for him?
So the first, when non-Datron customers come to us and ask about vacuum holding technology, here in the United States at Datron Dynamics, we do have an older vacuum option that can be retrofitted to non-Datron machines. We look at each of those very closely to make sure it's a good fit. Your biggest problems are if you're cutting it dry, it's possible. If you're cutting with flood coolant, it's not going to work. If you're using a large amount of like mist coolant and oil, that can also create an issue with the vacuum card sublayer. So if you're cutting it dry, it is possible, and it's something that we could definitely review. And you could reach out to the sales team here at Datron, and we can review any specific applications and see if it's a good fit.
Yeah, and usually, normally I would suggest, like if you're doing flood coolant, things like that, to use a gasket type. Pearson, there's more of a Venturi type for those applications.
Yeah, if you're cutting the same part repeatedly in a situation like that, that is where gasket, where you're loading it up, it's the same cutout every time. That gasket works great on something like a Pearson.
So here's another question. This is from a customer. They have an MA Cube. It's been really great for cutting sheets of aluminum and polycarbonate on both sides. The one problem we have is getting quality flat aluminum plate. Sometimes it is warped so badly up to 30 thou that it doesn't hold all the time and it pops up when you cut through. Any thoughts?
Yeah, so that can be an issue. So that's where sometimes it's worth spending the money on something precision ground, something that's stress relieved. There's a bunch of different options that if you reach out, we can help look at your specific scenario and see what'll work. But yes, that is a problem. If you get lower quality aluminum, it's going to have stress. All of it's going to have some stress, but if you have a lot of stress, it's going to pull it flat like you've seen, and then it's going to pop up when it relieves stress. So if you reach out, we can talk specifics to that, and then you can reach out to service@datron.com or our service hotline, which you can find online, and they'll send you over to an applications engineer, and we can help walk through any of those issues.
Next question here. Is there a specific type of pump you recommend? Also, how close does the pump need to be to the machine?
Yeah, that's a great question. So right now we sell with our equipment, our machines, Bush vacuum pumps. So Bush the manufacturer, and we sell a wide variety of sizes. And how far the vacuum pump, they typically recommend 50 feet, and with the standard size hosing. You can move it further, you just have to increase the hose size. So we have customers who remotely mount these. Some do it in a utility room and actually capture the heat and reuse it to heat their buildings in large setups. And you just have to size the hose correctly. And that's something we walk through. If that's something you're looking at doing, that's definitely something we can help support. And we have great contacts at our vacuum pump manufacturers who can help guide you through that.
And I don't know if this is the same person, but it says, any pump cover recommendations, vendors to lower the noise? I could probably answer this one. I've seen a couple recently.
Yeah, if you've got a better answer, mine is I've seen some, but yeah, you might have a better one.
It's not an approved thing from us, but I have seen some customers using like a zombie box. They're normally used for generators for RVs, things like that. They make them large enough to go over vacuum pumps. Main concern that you need to be aware of is that there's enough airflow. So if you do design your own enclosure, you have to have enough airflow to not affect the pump.
Yeah, and if you're working through that, that's something between me and Chris. We have a lot of experience with customers who try different things, success stories, failure stories. Yeah, like Chris said, the important thing is thermals. We had a customer who enclosed it in a box and ended up overheating and caused issues. So we worked with Bush on that particular case and found a good solution. Most customers, if you have the luxury, remote mount it somewhere where they don't care about the noise and the heat and they move it around. The nice thing is they're fairly quiet depending on the size. For the Neo, a lot of people are working right next to them. For MA Cube, ML Cube, the larger pumps in the 100 to 200 CFM, they're usually moving those somewhere 20, 30 feet away from the machine, and hopefully they have somewhere they can remotely mount it, or they're building some sort of quiet box with proper air ventilation.
You mentioned that the vacuum level is displayed on the monitor. Is there an automatic alert in the software if it detects a sudden drop in the vacuum to pause the program or alert the operator?
Yeah, that's one of the really nice features about Next is they've kind of put all the features in there to help you protect it. It's even in our old control. There's actually a setting where you can go in. So on the Neo, on the Series 2 Neo, there's an actual SMC unit, pressure unit in the bottom. You can program it and it'll just be an on-off signal. And then there's a digital readout on the larger machines and the Series 3 where you can actually dial in the exact pressure and it'll pause, and it both ends up in the same situation where the control will pause. It's the same as if you hit the pause button on the remote, it'll say, warning, low workpiece vacuum holding. It'll pause the thing and you can go fix it. The nice thing is typically it's probably, if it's shifted at that point, the nice thing about it is you can just go set it up in CAM, redo your origin and reprobe everything and probably continue and save your part. But yes, you can set it up to pause.
And can that alert, I know there's an app now that you can monitor the machine from. Will that alert go through the app as well?
Yeah, so the Datron Live app, there's a couple of different variants of it, but essentially you can have the cockpit app, which allows you basically to see the status screen and it'll alert out when it pauses and let you see what's going on. So that can be really helpful.
Did we already answer the one that says there are other sacrificial materials you can use in different situations instead of vacuum card?
Yep. Yeah, there's like we said, there's a ton of different options. So if you ever want to talk vacuum work holding sacrificial layers, feel free to reach out to us and we can give you some advice.
Okay, so I think we made it through all of our questions here. We hope that we've given you some great information there, and thank you for taking the time to join us in bearing through this with us. This is our second one, and they're going to get better and better every time. But yeah, we'll be sending out an email for our next one. It should be in the next month or so. Email will be going out, and we look forward to hosting again. Thank you, everybody, for your time.
Thanks, everyone.